want to talk a little bit about higher level sort of programming concepts. I'm very conscious that usually in our lectures we're talking a lot about basic level stuff, integers, ifs, whiles, all that kind of thing. But in many ways the real work of programming is far above that level. It's in the design of how objects interact with each other. I think one of the prime examples of that is in how we get, say, in a non-trivial program that hopefully will have a graphical interface, how we get the interface that the user sees to interact with the code at the very bottom of the pile and the business logic. So when a user clicks a button on their interface, let's say they're using Skype and they click whatever, dial mom or dial dad or something, that sets off a chain reaction of little bits of code executing in various layers to get right down to the very bottom layer where it looks for IP addresses and communicates with the network and figures out telephone numbers and that sort of thing. And usually the way we keep those sorts of things separate is what's called the model view controller pattern, where basically if we really think about it, there's two major layers to an application. There's the model, which is the bottom of the iceberg, the real sort of weight of the actual program. And then there's the little bit at the top, the view that the user can actually see. And in most cases, that view is a tiny, tiny fraction of what the program actually does. But it's what the user sees and it's what they use to interact with. So right away we have the view and the model. Forgive the terrible handwriting, I've never been able to write properly. And that's fine. So what we want in the view is basically things like our window, maybe a button, labels for things, bits of text, buttons to click on, all that kind of stuff. And in the model, we'll have all the actual business logic of figuring out the real things that the user wants to do. Another example might be, say, if you're using Microsoft Excel, where you see things in a grid, but that's not necessarily how it's represented in the data structure below it. And when you type in a formula to a piece of the window, the formula doesn't get executed in that piece of code that represents the window. It gets passed down to the model layer where that weird mathematical computation will be done. And then the model will figure out what the result of it is and pass that result back up to the window. And then the window will display it. But to the user, it kind of looks like it's all happening in the one space. Whereas from our perspective, there's several compartments that the program runs in. And it's kind of one of the fundamental points of object-oriented programming is to keep all these things separate and have all the objects be as blind to each other as possible. That the view shouldn't be fully aware of what's going on in the model, and the model should more or less be completely unaware that there even is a view there. And that becomes very useful later on when we start testing our program, because it becomes a bit of a nightmare if we have to run the entirety of the program at once to test any one part of it. Like say we want to test some component in the model, it becomes a bit heavyweight to have all of the view stuff running at the same time. It could get a bit weird trying to track down a bug that exists in the kind of little layer between them, if both of them are running at once. But if you keep them nice and separate like this, we have a distinct model object and a distinct view object, hopefully we'll be able to run the model without a view ever being attached to it, and maybe have our output come out on the command line or something along those lines.